Welcome to the Two Beans in a Pod. Today, we're embarking on a deep dive into one of the most powerful and visible forces shaping our planet. We're talking about the Earth's incredible, sometimes pretty unsettling restlessness. You've probably heard the headlines recently. There was that powerful magnitude 8.8 M8.8 megaquake off the coast of Kamchatka, Russia. And then, much closer to home for a lot of us, a magnitude 4.3 tremor that gave the Los Angeles basin a good rattle. Now, these events, they happen miles apart, but they're actually part of a larger and really fascinating story. So our mission today is to unpack these recent seismic and volcanic events. We want to connect them to the incredible geological forces at play around the globe and maybe explore what might be next for the planet. And we'll do it all in plain language, without getting bogged down in too much jargon. We really want you to feel well-informed, curious, and maybe just a little awestruck by the sheer power of our Earth.
Absolutely. And what's fascinating here is that these events, they're rarely isolated incidents. Not really. Instead, you can think of them as threads in this dynamic, interconnected system. So we'll be looking at how the Earth is constantly reshaping itself, offering insights not just into what is happening, but critically, why it matters, and maybe what we can learn from all this ongoing geological drama.
Okay, let's dive in. Let's unpack this incredible phenomenon known as the Ring of Fire. It sounds dramatic, and, well, it really is. Imagine a massive horseshoe-shaped belt. It stretches over 40,000 kilometers, that's about 25,000 miles, surrounding most of the Pacific Ocean. And this isn't just some random area on the map. It's home to about 75% of the world's active and dormant volcanoes. And get this, it's where a staggering 90% of all measured earthquakes happen. It's like the planet's ribcage groaning or its teeth grinding deep down.
Yeah, it's intense. And the core reason for all this activity is a process called subduction. Sounds technical, but the idea is pretty straightforward. It's basically where one tectonic plate, these giant segments of the Earth's crust, plunges beneath another one. So when the denser oceanic plate gets forced under another plate, maybe a continental one, it sinks down into the mantle. And down there, the intense heat and pressure cause it to melt into magma, molten rock.
Ah, okay, so it melts down there.
Exactly. And this molten rock, this magma, is buoyant, so it rises towards the surface. And that's how you get volcanoes forming along these zones. At the same time, the grinding of these colossal plates against each other generates immense stress. Just imagine the friction.
Right.
And eventually, that stress has to be released. That release is what we feel as an earthquake. It's this continuous, really dynamic process, been happening for billions of years, shaping everything we see. And the scale.
Yeah.
It's mind-boggling. This slow, relentless movement releases energy equivalent to hundreds, maybe thousands of atomic bombs over geologic time. It's literally reshaping continents, millimeter by millimeter.
Wow. So if I'm picturing this right, it's not just a gentle slide. It's like immense friction and pressure building up, sometimes for centuries, then bam, it suddenly lets go. Is that where the mega and megaquake comes from? Just the sheer scale of that buildup and the rupture?
That's exactly it. Megathrust earthquakes, like the one in Kamchatka, happen at these subduction zones and involve huge sections of the plate boundary rupturing. But it's also important to understand something about the name Ring of Fire. Despite how it sounds, it isn't one single connected structure where, say, a volcano erupting in Indonesia directly causes an earthquake in California.
Okay, that's a key point.
Right. Each of the, over 450 volcanoes and the countless fault lines within the ring, they each have their own unique personality, their own history. They're all linked by the common process of plate tectonics, sure, but the idea that an earthquake in Japan will directly trigger one in Chile, that's generally a common misconception.
Gotcha. Different segments moving at their own pace.
Exactly. Each part of the ring is its own distinct plate boundary.
Okay, now let's connect these big geological ideas to the specific headlines that got us started. On July 30th, 2025, the Earth really shuddered when Russia's Kamchatka Peninsula buckled under that magnitude 8.8 megaquake. Reports said it was a shallow and sudden event, and it registered as the sixth strongest earthquake ever observed with modern seismic equipment. The strongest since that devastating Fukushima quake back in 2011.
Yeah, the Kamchatka event was just a massive release of energy. It happened along the western Pacific side of the Ring of Fire, and the effects were immediate and widespread. It triggered tsunami warnings clear across the Pacific. Over 2 million people had to be evacuated in Japan. Waves surged over 5 feet high in Hawaii. And officials as far away as Chile, Ecuador, even California were bracing themselves. It really demonstrates the immense power of these megathrust earthquakes, the biggest kind, which happen right at these subduction zones, where one plate dives deep under another. And locally, of course, in several Kurils, Russia, there was significant flooding. Plus, the shaking didn't just stop. There were, I think, 24 aftershocks recorded, some quite strong themselves. It's a reminder of the immediate sort of cascading impacts these huge events can have.
Then, thousands of miles away, totally different environment, the arid sprawl of Southern California. The ground shuddered there, too. It was a magnitude 4.3 tremor near Fontana, pretty shallow, about 3.3 miles deep, made it one of the strongest quakes registered in California for the past month or so, and over 7,000 people reported feeling it to the USGS. Now, scientists are clear, right, this specific LA tremor isn't related to the Kamchatka megaquake across the ocean.
That's the scientific consensus, yes. There's no direct triggering mechanism across that vast distance. But it is a stark reminder, as you said, that California is incredibly seismically active. It sits right next to major fault systems like the San Andreas. And this raises an important point about how we, the public, perceive connections between these distant events.
Yeah, I can see why people would link them mentally.
Understandably. While scientists know direct triggering across oceans isn't typical, the sheer scale of that M8.8 in the Western Pacific, it does highlight the dynamic changes happening at that specific plate boundary. And California, even though it's on the Eastern Pacific side, is still technically connected to all these global dynamics through the Ring of Fires, let's say, broader system of plate interactions. So while it's not a direct trigger, the whole global system is, in a sense, always adjusting, always under pressure.
That's a really crucial clarification. But I imagine it's tough sometimes not to connect the dots, given how active the Ring of Fire is generally. So maybe a nuanced question. Are there any rare exceptions? Could huge events subtly influence very distant areas, maybe through long-range seismic waves or tiny changes in the Earth's overall stress field?
That's a great question. It gets into the subtleties of global geophysics. And the answer is possibly, but very subtly. While direct triggering is rare, some research suggests that extremely large earthquakes might slightly increase the probability of seismic activity in distant fault zones that are already stressed, already near their breaking point.
Okay, so not like dominoes, but maybe like a tiny nudge to something already teetering.
Exactly. More like a gentle nudge to a system already on the brink. It's an area of active research. What we observe more commonly are these less dramatic but still significant ongoing shifts all around the ring.
Right, and Kamchatka and LA weren't the only recent hotspots, were they? We've seen quite a bit of activity elsewhere along the ring. Like in the Philippines, Mount Canlaon on Negros Island, it's been erupting on and off since June 2024. 4 major eruptions in the last year alone, I think, including one in May 2025 that shot ash nearly 3 miles high, displaced thousands.
That's right. A very active period for Canada.
And then on Flores Island in Indonesia, Mount Liutobi Laki-Laki erupted twice, just on July 7th, 2025. One blast sent ash over 11 miles high.
Incredible plume heights. Shows the power involved.
Up in Alaska, too. Mount Shishaldin has been erupting intermittently since 2023, with new explosions in June and July 2025 sending ash columns way up, over 30,000 feet.
Shishaldin is one of Alaska's most active.
And even way down at the southern end, in Chile, the Villarrica and Naima volcanoes showed increased activity, more degassing in late June.
Yeah, so it's not just earthquakes. The volcanic activity is significant, too. And beyond these headline-grabbing events, there's constant, less dramatic stuff happening that scientists are getting better at detecting. For instance, deep focus earthquakes, sometimes called silent slips, were detected mid-July down in the Tonga Trench. That's over 500 kilometers below the crust.
Wow, that deep.
Yeah, subtly realigning faults without us feeling a thing on the surface. And there have been undersea eruptions detected near the Mariana Arc in July. Just sensors picking them up, quietly building new land beneath the ocean. And even the atmosphere gets involved. Satellites actually captured these things called atmospheric gravity waves radiating from the recent Indonesian, Russian, and Canlaon eruptions.
Gravity waves in the atmosphere like ripples.
Essentially, yes.
Yeah.
Massive ripples in the air that can travel huge distances and can even subtly influence weather patterns thousands of miles away. Maybe by tweaking jet streams or affecting cloud formation.
That's incredible.
It really shows how complex the system is. What starts as molten rock deep underground can ripple outwards, even affecting the air we breathe.
It's amazing stuff. And as we're unraveling these complex systems and exploring just how dynamic the Earth is, we really hope you're finding these insights as fascinating as we do. If you are enjoying this deep dive and you want to stay well informed about this kind of thing, please do remember to hit that like button and subscribe to Two Beans in a Pod. It helps us keep bringing you these explorations of the forces shaping our world.
Definitely. So with all this activity buzzing around the Ring of Fire, the big question a lot of people have is, what does it mean for what's next? It's the big one coming. Well, it's critical to understand that certain areas are, geologically speaking, overdue for significant earthquakes. California is a prime example. Both northern and southern California, particularly along faults like the San Andreas and the Hayward Fault near the Bay Area, they're definitely carrying accumulated stress. So while that M4.3 near Fontana isn't a direct predictor, it absolutely serves as a powerful reminder of this underlying seismic reality. But what's really interesting now is how these smaller quakes, and even those silent slips I mentioned, are giving seismologists just unprecedented amounts of data. They can map stress accumulation with a clarity that just wasn't possible before. It's fundamentally changing how we understand what overdue actually means. We're not just waiting anymore, we're learning more constantly.
Okay, that makes sense. More data, better understanding. But this next point, this has direct implications for millions of people, especially those living on the west coast of North America. We need to talk about the Cascadia subduction zone. It stretches all the way from Northern California up past Oregon, Washington, into British Columbia. And scientists are pretty clear it's overdue for a massive quake, potentially just as large, maybe even larger than that recent Kamchatka M8.8 event.
That's the reality, yes. Cascadia is a major subduction zone capable of generating M9 earthquakes.
And this isn't just theory, right? The last time it ruptured was in the year 1700. It caused a huge tsunami that we know about, partly because it actually left geological traces over in Japan.
Exactly. The historical and geological evidence is solid.
So if it snaps today, cities like Seattle, Portland, Vancouver, they could face just immense catastrophe. Tsunami models show waves potentially reaching, I've read, over 1,000 feet tall in worst-case scenarios along certain parts of the coast.
The potential impact is enormous, particularly from the tsunami.
Experts put the probability at something like 15% in the next 50 years, which sounds maybe not that high. But, as the sources always remind us, the Ring of Fire doesn't care about our calendars. It operates on geologic time.
Precisely. Those probabilities are useful for planning, but they don't tell us when. It could be tomorrow, or it could be decades from now. And while predicting the exact timing of earthquakes remains incredibly difficult, maybe impossible, these projections absolutely underscore the critical importance of preparedness. The good news here is that warning systems are getting better. We saw them work reasonably well, giving alerts for the Kamchatka tsunami in Japan and Hawaii. They're constantly being improved.
That is good news.
And communities all along the Ring of Fire are actively investing in resilience. You see it in Japan's nationwide earthquake drills and their focus on emergency supply kits. You see it in California's stringent building codes, even grassroots efforts, like hazard mapping in Chile. And beyond just personal readiness, all this activity is driving incredible innovation in early warning systems. Japan's seismic network, for instance, is a global benchmark. So understanding these forces means we're not just preparing for the inevitable, we're also continuously innovating how we live on this restless planet. Which brings us back to the crucial question. What can you, the listener, do to be ready? The baseline is always having at least 72 hours of emergency supplies. That means water, non-perishable food, a flashlight, batteries, maybe a hand crank radio.
The basics.
The absolute basics. It gives you immediate self-sufficiency in the critical hours and days after a major event, before wider help might arrive.
So, as scientists gain this, as you said, unprecedented clarity on stress buildup and fault behavior, how does that shift our relationship with the planet? Are we moving beyond just, fear or awe to maybe a deeper, more informed kind of coexistence?
I think so. I hope so. It feels like we're shifting slowly from a purely reactive stance, just dealing with disasters after they happen, to a more proactive one. We're still humbled by the Earth's immense power, of course. How could we not be? But we're also getting better equipped to understand its patterns, its language, if you will, and to prepare accordingly. It's really about building resilient societies, communities that can absorb these shocks, whether they're earthquakes or eruptions, and bounce back more quickly. It means recognizing that living on a dynamic planet requires constant adaptation.
Yeah, the Earth is alive. Its crust is this cracked shell, always shifting, always humming underneath us. And the Ring of Fire, that's where the shell is thinnest, hottest, and definitely the most active. What's happening now isn't entirely new in the grand scheme of things, but maybe it feels louder because we're listening more closely with more sophisticated instruments than ever before. And perhaps that's the real message here, that even in our age of constant information, constant noise, there's still this fundamental force that truly humbles us completely. The Earth herself, she has no politics, no ego, no hesitation, just pressure building up and then eventually release. Well, this deep dive into the Ring of Fire, it really shows us the raw, magnificent power of our planet, doesn't it?
It certainly does.
It's a constant reminder that we live on this incredibly dynamic Earth that just continues to shape itself in ways that are sometimes subtle and sometimes incredibly dramatic. Understanding these forces and preparing for them seems absolutely key to living on this amazing, restless world. We really hope you found this exploration as fascinating as we did. If you enjoyed this deep dive, please, one more time, remember to hit that like button and subscribe to Two Beans in a Pod for more insights into the world around us. Your support genuinely helps us bring you more of these conversations. Thank you for listening to Two Beans in a Pod.